Experience an evening of innovation to engage with a new generation of yacht owners. Revolutionize the industry as we know it and place yourself at the leading edge of the trend curve. This is VriThink's Night Out. This is your future.
My name is Willem Derks. I'm lead software developer. And I'm here to talk to you today about new solutions in software and how they can help build ships. What we focus on is building ships the way they're still built, from metal. Ever since software and computers were introduced in the design and engineering process, they alleviated the engineers, they made stuff easier, automated stuff. And we're now at a point where we can create a complete 3D structure of what we need to be building, rotate it, and have every detail in it. And what we're focusing on today is that first step from a virtual model to a real-life 3D metal construction that's welded together. And that process of going from virtual to real life is, as many people know, quite complex. You need to extract data from a 3D model. There's a logistics going on. Plates need to be formed, transported. You need markings on them. So the guys on the shop floor need to have their information how to weld stuff together. And this is, as everybody knows who's ever done this, a cumbersome process. You have software that's not compatible, communication issues, and what happens often is that issues kind of trickle down the line, and you end up with parts on the shop floor that are not fitting or inefficient. And we at OnePush thought, we can do that better, probably. It's 2020, so. And the way we tackled that is we started on the shop floor. We asked the guys welding stuff together, okay, what are the issues that you run into? How do you do your work? What do you need? What are your needs? What is lacking? And we worked our way up in the supply chain, formers, prefabrication, all the way up to the desk of the engineer. And what we saw happening time and time again is that it is a process of step by step by step, but it's a linear process. There's no feedback loops. There's issues with incompatibility, but it's not something that people do together. And that's what we envisioned. We envisioned, what if we do that in one process and we do some sort of simulation of the build? We say, okay, we have one process, we act like we're going to build it, and then we get issues, and then we can still solve them because we haven't built it yet. Because if you have to solve stuff once you have it on the shop floor, it's much harder. To make this accessible to everybody in that supply chain, we envisioned a system online, a platform, where everybody that needs to give input can log in with the browser and have that build visualized. And before everything starts to roll, you all come together. People can give feedback, so you have iterations. The images of uploading your 3D model in the cloud, and there we needed software to do that simulation of building. There was nothing available, so we need to build that ourselves. And what we built was a system, a software engine that analyzes parts, individual parts. Can this part be made? Isn't it too big? What type of stock material do I need? And then analyzing it in the context of the complete structure. And once you have that, you can use smart algorithms, and you can use all the input we collected on the shop floors and in that supply chain, and analyze, okay, what type of build is this? What type of parts need to be formed first? And what types can be directly put into place on the shop floor? And all that data is collected and presented to all the specialists, the craftsmen, and they, before the build is even started, can react on that. They can detect stuff, and they can add their own preferences. I want these parts to be shipped there, these need to be formed. Hey, this is wrong, I need to give a notice to the engineer, and he can update the model. So we had that running, that system of a software engine that scans and kind of simulates the build. And what happens if you have that, then the output is geared toward the needs of these people in the supply chain. So if you go plasma cutting, you need different types of markings than if you have the ability to mill and print in color on two sides of a plate. And the guy who's going to do that gets the files exactly as he needs to, because it's built in the system. The system knows he's going to make it, so we send it out like that. Guys on the shop floor, they get their plates with manuals on them almost. You take the part and you see, how should I make this? What are the dimensions? What goes where? Same applies to the former. If you have plates, the system recognizes, hey, these are bent or these are formed. Let's make a mold. And that way you automate almost everything that is obvious. Everything that is known or obvious or is added by customization is done by the system itself. What is left is that customization. This is an actual screenshot of the portal we're going to go live next year, where after uploading the model and all that data is added, you have a visual and intuitive system to filter and visualize your data, to add comments, to add customization of data streams, of feedback loops. So before the build is done, everybody in the supply chain has added their comments and their preferences, and then, only then, you start producing. And for us, that is kind of the vision of the future of how software tools are going to help us. The software tools have built-in smartness, built-in intelligence, and do everything that's obvious, everything that is straightforward, and it leaves for the specialists, the craftsmen, to add their valuable time to that process and to customize it and to tweak it, and also to leave time to do interesting and new stuff. Yeah, that is our vision of the future. And currently, for us, it's already reality. We've been running this for 2 years, doing hundreds of projects. Currently, we're building the largest aluminum yacht ever built with our software. Thank you very much.